class. We're talking about hose operations and hose strings. So when we left off, we were talking about reverse and forward lays and the benefits and the disadvantages of them and things like that. One of the discussion questions that we could talk about was provide an example of a situation that would require the use of a forward lay in our district, and then we could talk about a situation that would require a reverse lay. So let's start with a forward lay. What would be the beneficial for us to use a forward lay in our district?
Any place we had a long place to go, where you couldn't get another truck or that up there where you can supply the line.
Yeah.
Order right up there to the pumper.
Yeah, absolutely. Anybody else?
This situation for a reverse lay, we like Dollar General, we would have to drive past the scene to get to it hydrant.
Yeah. It'd be kind of conducive to drive past it and then try to do a forward lay back into it. And you know, with Dollar General, that the odds of us having a ladder truck coming there is probably gonna be pretty high, especially if it is actually on fire. And another reason, example of why we would need a forward lay in our district as opposed to reverse lay is just so that truck is up there with us, so that way all of our equipment is there with us that we may need while we're doing this fire attack.
Most generally, you're gonna try and have the pumper up there where the fire is anyway.
Exactly, because you want to make sure you leave all the equipment up there.
Because it's hard enough to get around it with too many trucks anyway, so.
Right.
You want your main truck up there.
Exactly.
And also, the forward lay helps with communication.
Because the operator can be up on the scene and see what's going on and stuff like that, and he doesn't have to rely on radio communication from somebody else to tell him what's happening. So yeah, all great stuff, guys. I appreciate it. You guys are really doing a good job. All right, so we're going to talk about deploying pre-connected hose lines. One of the most popular ones used in the fire service is advancing a Minuteman hose load. There are a couple different ways that we can deploy hose sections. Flat load, accordion load, and a horseshoe load. And I'm sure we'll go through some examples of those. Flat load is going to be your most common because it will fit in just about any space that you need it to fit into. The accordion is just a little bit more complicated to do, but it's really nice if you're on scene, and it's really nice for like a hotel pack. You can make an accordion, squinch it together, tie it off, and then you can carry it wherever you need to. Then a horseshoe load is just a horseshoe load, you know, I mean, it takes up a lot of space. It's not really practical. We're gonna talk about a bursted hose line. So your water pressure will decrease or water flow may stop completely if you have a busted hose line. And the only way you're gonna be able to fix that problem is replacing it. And that's where that hose clamp comes in, that's where your gate valves come into play, so that way you can shut down that line really quickly without having to shut down the whole operation to change out those busted hose lines. So what are two methods that can be used to deploy pre-connected hose lines?
Minuteman, flat load.
Beautiful. Beautiful, beautiful, beautiful. All right. So which type of hose loads are commonly used in our jurisdiction?
Modified Minuteman or triple load.
That triple load, yep. What methods can be used to deploy these types of hose loads?
Not sure what they're asking, but you can carry them.
Yep, you can carry them, especially with our modified Minuteman. We put on our shoulders, and then you grab the other two lines with your right hand, and you can take off with it. And it really reduces the amount of kinks, tangles up in it, things like that. And it's easy to deploy because once you got that stack on your shoulder, once you get extended out, you get to the door, you can drop that line right there in front of it, flank it out, and it's ready to go. So now we're gonna, learning objective number 3, we're gonna describe some methods of advancing a hose line. Advancing a hose line over flat surface with no obstructions is a simple thing to do. You go straight in, straight out, and there's nothing in your way, it's gonna go really smoothly. Advancing a hose line up and down stairways, from standpipes, up ladders, and deep into the building is definitely more difficult. When you're going around up and down stairwells, when you get to that top of that stairwell and you make that right or left-hand turn, and you have to advance down the hallway, that hose is gonna get kinked on the corner there. It's gonna just make it, it's gonna add friction, it's gonna make it so much harder to try to pull it anywhere you wanna go, especially if it's charged. Uncharged lines are easier to advance, but it's obviously more dangerous also because you're in the middle of a house fire and your line's not charged. When they go to charge it, something happens to the pump, something happens, something's busted on your hose line, something like that, you may be up a creek. So it's definitely the easier method to do, and it's definitely doable, but it's also the most dangerous. It is often unsafe to enter a burning building with an uncharged line. Yes, it is, but if you have a hoarder's condition, that uncharged hose line is definitely gonna be a lot easier to maneuver through the house than it would be, with a charged line.
When you look at some of the situations that you would use an uncharged line, if you're working off a standpipe in a building,
Right.
you're gonna go in uncharged.
You are gonna go in uncharged, because you're hoping that your truck is hooked up to that standpipe and it's flowing water to it, so that way
Yeah.
when you connect to it, it's ready to go.
And you wouldn't wanna pull a charge line
That-
up 4 floors.
That would be terrible. You are absolutely right. That would be a benefit of the uncharged hose line. But again, it is still dangerous because you are going into a burning building with no water to protect yourself from. So this is something you have to keep in mind. When you're going in there with an uncharged hose line, you have to make sure you know what your exits are gonna be, your egress, all that fun stuff. Advance a hose line into the structure, you got a working line drag. This is gonna wear you out really quickly, but it's doable, you can definitely move it. Some safety guidelines for advancing a hose line into a burning building. Check for heat using a tick or a water spray. You can use a little bit of a fog spray and you can see how fast the water dissipates. I'll tell you how hot it is. Stay low and avoid blocking doorways or windows. Hopefully you're controlling your airflow and you're keeping those doors and windows closed behind you. Keep the door closed until you're ready to enter. Control openings to limit flow path effects. Chalk self-closing doors to prevent the door from closing or pinching the hose line. Like our compressed doors here, you want to make sure that you have a wedge that you can shove in there so that way it doesn't come back and shut down your hose line. Especially if you go in uncharged and then that door closes behind you and you go to charge it, it could pinch it, and then again, you don't have water. It is good safety practice to assume that there is heat behind every door. So you should always make sure that you check it, always be cautious knowing when you enter there that you're gonna potentially have a lot of heat hitting you. Advancing a hose up a stairway, keep the stairs as clear as possible, avoid sharp bends and kinks in the hose, if possible position firefighter at every turn or point of resistance. Hopefully you don't have to go up too many stories, hopefully it's just a 2-story house, you have one firefighter at the corner, he's dragging that hose up while the nozzle man is advancing forward. Once the nozzle man gets to the seat of the fire, then you can join him to help him, or stay in that position because he's gonna be ready to back out. You wanna make sure you can back that hose back out for him so it's not getting all wadded up behind him and he gets stuck. Advancing down a stairway, advancing uncharged hose lines is easier, but only recommended when fire is minor or not present. Just something to keep in mind, while advancing an uncharged line is easier, an uncharged line offers no protection if fire conditions worsen. Charged lines are definitely always going to be recommended. And there's just a lot of things that could go wrong while you're in there that if you didn't charge that line before you went in there, you just don't. It's a lot of unknown. Advancing down the stairway, exits, hose should be stretched outside the stairway, especially if you can find like an offsetting room. Open that door and try to put your access hose in there so that way it's not wadding up at your stairwell, and if you try to have to do a quick egress, you're not tripping over your hose line. Firefighters position at the stairs to feed the hose to the nozzle team. Firefighters position at the corner of the pinch points and have enough hose to stretch to reach the fire. So you want to make sure that you can make it to the seat of the fire. It'd be really embarrassing to get all the way up there and then not be able to put the fire out because you ran out of hose. That high-rise pack, that accordion load that I was talking about, that Tom was talking about, that we would have to go up with an uncharged line. That's what it's gonna look like. It's on our L2 compartment in our truck. It's a bundle put on your shoulder. We have fire department connections over a jury, is where we're probably gonna use that more than anywhere else. And, so you get your truck hooked up to it, you take that hotel pack, you go up to whichever floor the fire is on, the standpipe's gonna be at the end of the hallway, connect it up, get that line charged, and go fight fire. While you're operating with a standpipe, you wanna be alert for pressure relief devices. Gated wires can be used to help just alleviate that pressure off of the line if you need to. While connection is made, extra hose should be deployed up the stairs. So here's some examples of the hose. You can see they got the standpipe here. They put down some excess here. They're going up, excess up here while they're finding the seat of the fire. You want to try to keep the excess out because you want to leave your egress of the stairs open. What's that?
They put a Y appliance on that.
They did, yeah. There's you can see that they have a Y here. They got two lines coming off of it. So that way they have two nozzles up there to attack the seat of that ginormous fire that they have pictured up there. Improvising a standpipe. Again, we're talking about that fire department connection. Oh no, this is they apparently used a drone to get the hose up there and used a ratchet strap to support it to the solid beam there and had the nozzle go there. And this looks like a lot of work, but you can see that they have the hose line there. We wouldn't have enough hose on our initial pre-connect to make that stretch on either one of those. And we don't have a drum to get it up to the 4th floor, so. I'm assuming that what they probably did is they went out with an uncharged hose and then dropped it down. But a drone would be cooler.
Coming soon. Coming soon.
Yeah, coming soon to a firehouse near you. So just remember some caution things. When firefighters must improvise a standpipe system, there will be delays in applying water to the fire. This delay must be considered in planning the overall firefighting. So, that standpipe fails, you gotta drop that, you gotta try to make access to that hallway to drop down that line so that way you can modify your standpipe and get water to the seat of the fire. Advancing the hose line up a ladder. I think, in my professional opinion, advancing a hose line up a ladder is significantly more dangerous than an uncharged line into a fire. Because you're on a little bitty stick and, if your operator's not paying attention and he ups that pressure on you and you're up on the 2nd story window and you fly backwards because of the pressure, that's gonna hurt. It's easier and safer than an uncharged line. Again, I don't think so, but the book says so. Firefighter heeling the ladder can feed the hose to those on the ladder. Only one person per ladder section, and rope hose, tools, or utility straps can be used for advancement. Do not exceed the rated weight capacity of the ladder. The hose cannot be passed up the ladder without exceeding the load limit. It should be hoisted up. And that's where your webbing and your ropes and stuff like that comes into play. What are the differences between advancing uncharged and charged hose lines?
Uncharged is easier but more dangerous.
Charge line's gonna be a whole lot heavier.
Yeah, it will be. It's also gonna be harder to get around those pinch points and around those corners and things like that. A charge line is definitely gonna make things a little bit more challenging, but fire flashes over on top of you, you have guaranteed water right there that you can start putting the fire out above you. Or that uncharged hose line, it flares up over you, you gotta wait for the operator to, hopefully your operator's ready to go and he's not, running a sledgehammer to somebody real quick or something. Alright, so objective number 4, we're gonna differentiate among types of hose strings and nozzles. The fun stuff. Factors that affect the hose string: velocity of water extinguishment agent, flow rate of water extinguishment agent, gravity, wind direction and velocity, air friction, operating pressure, nozzle design and adjustments, and conditions of the nozzle opening. So this is really important why you check your nozzles. Make sure that they're set at the right gallons that you're going to be pumping at, that they're able to freely move and operate properly. If you're using a combination nozzle, you want to make sure that that bell will move properly. Some hose string uses, will apply water or foam onto a burning material to reduce the temperature. Applying water or foam into open flames to reduce temperatures so firefighters can advance hose lines. So, put the fire out, right? Hose string uses, we're gonna reduce the temperature of upper gas level layers, dispersing hot smoke and fire gas from a heated area, creating a water curtain to protect firefighters and property from heat, creating a barrier between a fuel and a fire, and performing hydraulic ventilation. So with your hose strings, you can do all kinds of cool stuff with it. You put that wide fog pattern on at the window, you gotta circle it around, it's gonna help push that smoke out of the house and do some, do that hydraulic ventilation. While you're protecting your exposures, you know, you wanna create that water curtain to protect your exposures, make sure that, you know, the fire's not spreading to other things around them. You know, the purpose of water on the fire is to disperse the temperature and the heat, so that way the fire will go out. Some hose strings, we got, describing some hose strings, we got patterns that they form, nozzles that create the patterns, types of control valves, and factors that limit a hose string. String quality and reach, you take the size of your nozzle opening plus your nozzle pressure is gonna give you the quantity of water flowing from the nozzle. And then the size of your nozzle opening is your stream reach. So that fog pattern as opposed to a straight stream is gonna make your determination of how far that water is gonna reach. The straight stream is gonna reach a lot further than your fog stream will, which is the reason why a lot of people use smooth bores, because it's a strong, solid stream. Hose stream shapes, you got smooth bore nozzles and then you got solid stream. With the fog nozzle, you got fog stream and straight stream. We carry both on our pre-connects. We have a smooth bore on one side and we have a combination on the other side. The NFPA, the manufacturers, categorize nozzles that produce variable hose stream patterns as adjustable pattern spray nozzles. For the purpose of this medium, we will use the more common term among the fire service, fog nozzle, to describe these devices. So, when I say combination, I mean fog nozzles. Extinguishing properties of water, all the circles got to connect in order for this to work. Readily available, relatively inexpensive, greater heat absorbing capacity than most common extinguishing agents, absorbs a large amount of heat when it changes to steam, and can be applied in a variety of ways. Extinguishing properties of water, excuse me. So here's your water conversion to steam. Water and fire equals 1 drop per 1,700 steam levels. Good nozzle control and coordination with the tactical ventilation makes for effective, efficient, and safer hose stream operations of fire control. So this is where the communication is key with your ventilation crew and your nozzle man of, when they're ready to ventilate, you're ready to put water on the seat of that fire so that way you can get a good knockdown on it. Why is water an effective extinguishment agent?
Readily available.
Readily available, and it will, has the best agent to disperse that temperature. Just some notes here. NFPA 1963 is a standard for fire hose connection. Identifies 2 general categories of hose stream nozzles: straight tip nozzles and spray nozzles. For this manual, straight tip nozzles will be referred to as smooth bore nozzles, and spray nozzles referred to as fog nozzles. So hose string nozzles, we have a smooth bore, fog, and a broken string nozzle. They can control water flow, shape the water stream, and create reach. Here's some examples of your smooth bore nozzles. This is what ours looks like on our pre-connect, but it's also got a bell on it, it's like that to control the water flow. So your smooth bore nozzles operate at a lower nozzle pressure, so it's a little bit easier to handle, but it's also going to put out the same amount of water to disperse that heat. It's less prone to clogging with debris. Can be used to apply compressed air foam. May allow hose lines to kink due to less pressure. Do not allow for sections of different stream patterns. So a smooth bore is one solid stream. That's all you're gonna get. You can dictated a little bit, but it takes some maneuvering, and you gotta be skilled like Woody. Because a smoothbore doesn't require as much pressure, you do have to be concerned about those kinks and like that. So you just gotta make sure that that second firefighter is really watching those pinch points and stuff like that whenever you're going through a house. Here's some boring math stuff. Talking about flowings in gallons per minute from various size solid stream nozzles. I want you guys to memorize this, because it's definitely not gonna be on the test. More boring math stuff here for you guys. So this is flow in liters per minute from various size solid stream nozzles. Again, I want you guys to memorize this, because it will not be on the test. Alright, fog nozzle patterns. We got straight stream, we got a narrow angle fog, and we got a wide angle fog. So, that combination nozzle, that fog nozzle that we're gonna be talking about now, unlike the smoothbore, you can change the shape of the water for it. Fog nozzle characteristics is adjustable discharge pattern, can provide protection to firefighters with a wide fog pattern, used for a variety of applications, variety of nozzle choices and manufacturing options, can be used to apply certain types of foam. If you're gonna be using foam, your fog nozzle is gonna be your best to go with, just because you're gonna be able to manipulate that fog pattern, or that stream pattern, so that way you can get a good aeration for your fog, or for your foam. Words. Fog nozzles. So here's some examples of them. You have a basic fog nozzle, you have a constant gallonges fog nozzle, a constant pressure, which is an automatic fog nozzle, and a constant select gallonges fog nozzle. We have these three on our trucks. That basic fog nozzle, I've never seen it. But apparently it exists somewhere in the world. Abrupt changes in the reaction force of the hose line may throw firefighters off balance, also known as water hammering. That's whenever when the operator shuts down a hose line and he doesn't do it slowly, he just slams it closed. If you have another hose line operating, those firefighters are going to be thrown off, because it's going to send all that pressure to that line, and it's going to throw them back. Automatic fog nozzle flow rates. It's got high flow, mid-range, and low flow. You can adjust the gallons on the nozzle. Water flow adjustments in manual and automatic fog nozzles require close coordination between the nozzle operator, the company officer, and the pump operator. So fog nozzle pressures, you got 100 PSI, designated operating pressure for most fog nozzles. And then on your solid streams, you got 75, 50, or 45 PSI. Less nozzle reaction, greater droplet size, lower density fog pattern, and less velocity. Piercing nozzles, it's a broken stream delivered device. It's so you can puncture through a wall. If you have a closet that you can't get access to, but there's fire in there, you can use a piercing nozzle to pierce in there, and it's gonna send out a fog spray. It's going to dissipate that heat in that closet or that small space in order to get the fire out, or at least so you can gain access to it to get, a more solid stream on it. You got cellular nozzles, and then you got a Rockwood cellar pipe. The Brinson distributor, water will come out of there, so it'll kind of make like a water curtain. You can slide it in to a house if it's high heat, you just can't make entry into it, but it's going to cause a lot of steam. Nozzle maintenance, this is probably the most important part of your nozzle. You want to make sure it's always maintained, because it's got to be ready to go at any moment. Inspect after each use and at least annually. Perform maintenance, care, and cleaning in accordance with your manufacturer's recommendations, and only qualified technicians should perform technical maintenance. So don't go taking a nozzle apart if you don't know how to take a nozzle apart. Inspecting nozzles. Inspect the swivel gasket for damage or wear. Replace worn or missing gaskets. Look for external damage to nozzle body, couplings, and tips. Look for internal damage and debris. Check for ease of operation of nozzle parts. Ensure that the pistol grip, if applicable, is secured to the nozzle, and assure all parts are in place and in good condition. And then some nozzle care. Thoroughly clean after each use. Follow manufacturer recommendation for cleaning and lubricating moving parts. Store nozzle with control valve in the closed position. Never drop or drag nozzles. Use flush settings on fog nozzles to remove internal debris. And shut off water supply. Remove the nozzle and physically remove any remaining debris that might be in there. You don't want debris in there because as it swirls right in there, you see the pins that's like that at the end of the tip, that debris will damage that. And then your fog pattern or any kind of pattern you're trying to go with, it's going to be off and it's not going to do what it's supposed to do. Some review questions. What's some differences between smoothbore nozzle and a fog stream nozzle?
Smoothbore is superior.
It's a little biased, but accurate.
Fog streams are for carburetors.
I believe smoothbore nozzles require a little less pressure to operate compared to your fog stream nozzles.
Your smoothbores are definitely going to be nicer. Again, with our setting, 3 firefighters, that one guy's going to be making entry on his own potentially for a few minutes while the company officer is doing his 360 and the driver operator is doing his stuff. That one firefighter with a smoothbore is going to be able to handle that line really easily by himself, as opposed to a fog nozzle that's going to require 2, maybe 3, depending on what size diameter hose you're using.
Well, one advantage of the fog nozzle is you can open that thing up for your own protection.
You can. That absolutely. And it's also good for ventilation. You can, if you can get to a window and you need to ventilate the smoke out of that room, you can put on a fog nozzle and it will suck that smoke right out of that window while using a fog nozzle. You don't even need a fan. Not saying that fog nozzles are not important.
Oh,
They
no,
definitely
yeah.
got their places.
Yeah.
They're both just great tools to have on the truck.
The straight stream gives you your distance.
Yep, you got that right. Some nozzle control valves allow the nozzle operator to start, stop, increase or decrease the flow, open and close the nozzle slowly, and control increases to nozzle reaction. So your brain's the one operating that nozzle. You know when you want to open it and close it. You just want to make sure that you do it slowly because you don't want to cause that water hammering to the truck or the other firefighters. The ball valve sits right in the middle of it. And it's real self-explanatory. It's closed, that ball's gonna sweep open and close off that flow. When you open it, it's gonna move out of the way, and it's gonna let the water flow free. Slide valve, on the other hand, it's got like a piston in it, and it's going to exert back in when you close it, so that way it shuts off that line. A lot of your fog nozzles are gonna have the slide valve in it instead of the ball valve. Your smoothbores will typically have the valves in them. Rotary control valve operation, that's that front part that you can adjust to make your fog stream or your straight stream with your combination nozzles. Hose string patterns, your size, volume or quantity of the water flowing per minute, and then the types is your patterns or shapes of the water after it leaves the nozzle. For that fog nozzle, you can adjust the type of stream you want coming out. That far one is a master stream. It's a large diameter hose. Typically the nozzle is going to be mounted to the ground. You got a large hand line here that he's operating here, and then you got a low volume stream. Stream flow rates, more charts. So here's your different patterns. You have a solid, which is over here on the top right, your fog nozzle, your straight stream, solid, straight, and then you got your broken. The broken one is going to be your piercing nozzle, or that Brinson, your straight and fog is going to be off of that combination nozzle to fog, and then your solid is that smooth board. I don't know if you know this or not, but that big red thing is a pump. The red thing coming off of the big red thing is a hose line. And then you got a nozzle, and then you got the agent, which is your water. And I don't know why they didn't, but this is a firefighter. Solid streams, it produces from a fixed orifice, smoothbore nozzle, can reach areas other streams might not be able to reach, can penetrate and saturate burning materials or debris. So that's the benefit of a smoothbore, is you got a further reach, and it's going to saturate your fire because it's a solid stream that's coming Reach can be affected by gravity, friction with air, and wind, which is gonna be any hose line. Provide large amounts of water quickly. When solid stream contacts wall or ceiling, the broken stream provides greater surface area to absorb heat and can cool the compartment. So, you're in that, you're in that hallway, it starts rolling over you, you take this smooth board, you point straight at the ceiling, it's gonna hit the roof and it's gonna dissipate out, and that's what they're talking about, that broken stream at that point, and it's gonna protect you. Do not use solid streams or energized electric equipment, so don't use a smooth board on a Tesla car, it might make you feel a little wiry. Solid stream performance is a effective hose stream, does not lose continuity until it reaches the breakover point and falls into a shower of spray that are easily blown away, cohesive enough to maintain its original shape and required height. Performance depends on velocity and orifice size. So, that's what they're talking about with the velocity and the wind with your solid stream. Fog streams, it's a fine spray of tiny droplets, exposes minimum water surface for heat absorption, and stream performance characterized by amounts of heat stream absorbs and rate that water is converted to steam or vapor. Can be adjusted to the situation. Well, like Tom was saying, if you're inside and that fire starts getting hot, you can change the pattern of that stream, and you can protect yourself and get back out of that if you need to, whereas a smooth bore, you have to rely on a wall, ceilings like that to break that cycle up. Can be used for hydraulic ventilation, vapor dispersion, and crew protection. Expose maximum water surface for heat absorption. May be used to cool hot gas layers and hot surfaces. Fog streams shorter reach or penetration than solid or straight streams, can be more affected by wind than that of solid or straight streams, may disturb thermal layer if applied incorrectly, may intensify fire by pushing fresh air into the area. So that fog nozzle, we talk about using it for hydraulic ventilation. You can also push fresh air into that fire and make that fire grow instead of actually put it out, because those droplets are evaporating before it can cool the fire down. So just remember that when you're choosing your streamlines. So a narrow angle pattern is your highest forward velocity. Reaches varies in proportion to pressure applied. So if you wanted that narrow angle to reach, you gotta increase the pressure, which is gonna make it harder to hold that hose line. Wide angle patterns, less forward velocity, shorter reach. You gotta remember it's gonna be wide, so it's not gonna go that far because it's gonna be real tiny droplets. Your straight stream is pretty similar to a solid stream, but it's still in that fog nozzle, so it's still not a complete solid, it's still broken. So it's not gonna have as much of the gravity of it, it's like that, it's gonna be a lot further, but it's also not gonna have that penetrating into the heat like your solid will. There's an example of a broken stream with a smooth board. Hose stream limiting factors, gravity, velocity loss, water droplet friction with air, and a wind. How are solid streams, fog streams, and straight streams different from each other? If I remember.
Solid is solid, got longer reach. Fog streams, you can fog it or make a solid stream. Smaller water particles and droplets. And straight streams from a fog stream.
Perfect.
Or fog line.
What's the one major factor that's probably gonna limit the reach of those hose streams? Probably
Pressure.
What's that?
Pressure.
Pressure, yes, definitely,
Wind.
and wind. The wind is definitely gonna be a huge factor in your streams. All right, learning objective number 5, this should be our last learning objective. Explain how to operate different types of hose lines, nozzles, and master stream devices. Operating small hose lines, one firefighter method, small ground cover fires, your vehicle fires, rekindled during overhaul, rubbish or trash fires, fire in an outbuilding or shed. So your one firefighter is typically gonna be used on your smaller fires, things like that. However, as we progress in the fire service with limitations in staffing and things like that, we are learning how to safely operate in house fires with a one firefighter for a short amount of time until your second firefighter gets done with his task and is able to get in there and start helping. But there are techniques and there are methods to keep yourself safe and still efficiently put the fire out if you have to. Your two firefighter method, which is definitely the most recommended, the minimum number of attack line during interior operations. Firefighters may apply hose straps or rope hose tools to reduce nozzle reaction. So that line that that guy was carrying and stuff like that, that he was keep it close to his body. As you're opening and closing that nozzle, it's gonna jerk you back and forth. That strap is gonna keep it close to your body, so that way you're not tiring yourself out. You're using your core instead of you're trying to use your outer muscles to try to control it. On a two firefighter method, your nozzle firefighter holds the nozzle with one hand and the hose with the other. Hose line rests against the waist or the hips. Your backup firefighter, same side of the hose, about 3 feet behind the nozzle firefighter. So you wanna make sure that you're on the same side and you're only 3 feet behind them, because you still gotta have somewhat visual, so that way you guys can communicate back and forth. And then you don't wanna be on opposite sides of each other, because if you go around the corner, he's going this direction and you're on the outside part of it, it's gonna be all wonky and you're gonna create pinch points and things like that. So you don't want to be on opposite sides, you wanna make sure you're on the same sides. Must keep hose straight behind the nozzle operator. Do not direct the fog stream into a ventilation opening during offensive interior operations. If the interior crew is in the room or area immediately beyond the ventilation opening, do not direct the hose stream of any kind into there. You will have a lot of mad people, because you're gonna steam burn them, you're gonna hurt them, and if they're able to come out swinging, they're going to. So, if you have an interior crew, don't put any more water in that fire until they say they're out or it's safe to you. One firefighter method for large hose line operations. Used for exposure protection or overhaul if a master stream is not available. Firefighters can use hose straps or rope hose tool to reduce fatigue. Does not permit much maneuvering of the nozzle. So a lot of times you're gonna have that large diameter hose, you're gonna be sitting on it and you're just gonna be spraying water to make sure that the exposures don't catch on fire. Two firefighter method for large hose operations. Firefighters may need to anchor the hose line. Leaning slightly forward helps control nozzle reaction. So when again, that stands where you're kind of leaning forward, because that pressure of that hose line is gonna knock you back and forth. You got a good solid base. You're not gonna be fighting against it as much. So what's some ways firefighters control hose lines?
Putting their weight into it, kind of leaning forward.
Yeah, that's one way.
Strap.
Yep, a hose strap. Those are all good things to think about.
Sitting on.
Sitting on it.
When you got two firefighters, it's the guy in the rear that's gonna control the up and down movement of it.
Yep. Yep, and that's where that communication is key. All right, operating nozzle. Each nozzle handled differently at the recommended pressure. Nozzle patterns may affect ease of operation, velocity and flow rate cause nozzle reaction. One person can usually operate a nozzle on an inch and a half or inch and 3/4 or a smaller hose line. Inch and 3/4 or larger hose line require additional personnel. Friction loss. That's something you'll learn once you become a driver operator. Friction loss is increased by rough linings, damaged couplings, sharp bends, number of adapters, length of hose lay, and your hose diameters. So when they're out doing hose trainings like that, and driver operators yelling at you to be careful of those couplings, that's the reason why. It's because your friction loss is going to be affected by the damage that's done to the couplings and stuff like that. And then also your hose length and your hose leg. Overcome or reduced by increasing hose sizes, adding parallel hose lines, increasing pump pressure, or removing kinks or sharp bends. So this is a nightmare of friction loss here, because you got a ton of hose, you got kinks, you're gonna have a ton of friction loss there. Water hammering is what we were talking about. It's not literally a hammer on top of the water truck like this is apparently indicating, or I don't know why they have so many hammers on there.
Specific line.
There's a lot of hammers. That's when you're opening and closing valves super fast. You need to gradually close them. You gotta have control of your nozzle at all times. If you slam that pressure that's coming out is gonna come to an abrupt stop, and it's gotta go back. If your truck is pumping to other hose lines, it's gonna go back to the truck. It's gonna make the truck idle up on higher pressure, and then it's gonna send it out to the other lines, and then you're gonna throw those other firefighters around like that. So it's really important to maintain that good hose control. How can firefighters operating hose lines combat nozzle reaction? We'll just usually, let's say, master stream devices usually deployed when fire is beyond effectiveness of hand lines. There is a need for hose streams in areas unsafe for firefighters. So your master stream, you have it set up down here on the ground monitor. So we don't have an aerial truck that we're gonna be able to reach up that high, so we need a lot of water in a little space, so that's what we're gonna use as a ground monitor. Flowing a minimum of 350 gallons per minute, nothing less than 2.5-inch supply lines. Small, quick attack devices may be temporarily supplied by one 2.5-inch line. A third 2.5-inch line required when greater quantities of water are required. Some devices are equipped for one 4-inch or larger supply line. Master stream devices, large amounts of water accumulate inside the structures because you're dumping a lot of water out of it. At 350 gallons per minute, you're dumping a lot of water onto a structure. Deployment usually requires a minimum of 2 firefighters. At least 1 firefighter position at the device unless it is in a hazardous position. If the situation is too dangerous, it can be anchored into a position. So the nice thing about those master streams, if we have a hazmat, like a train car derails, you can set that ground monitor up, you can anchor it to the ground, you can leave it sit and spray water, you can get away from it. Just remember, you're adding a lot of water, so it's gonna add a lot of weight, and it's gonna compromise your structure and potentially cause collapse. Elevated master stream devices can apply water to upper stories as a direct attack or supply for hand lines. It can provide exposure protection and commonly deployed by quints, aerial ladders, and aerial platforms. Is there any questions about the content that we covered today? All right. Well, I appreciate you all coming in. I do have a test here for you guys to take. So, if you need a pen, let me know. Thank you, thank you, thank you. Thank you, thank you, thank you.
Steal your pen here.
Yeah.
Thank you.
You're welcome. Take this, thank you for signing in.
What's today's date, sir?
Huh?
What's today's date?
Today is November 10th,
Thank you.
2025.